Hi, this is Richie Sposato from Lane 1 Bowling. Today we're going to talk about how you can maximize the potential of your bowling ball. How to get the most hitting power, out of your ball, whatever layout you choose. And the way to do that is with the gravity balance system. Today we're going to talk about the center of gravity of a bowling ball. What is the center of gravity? Well, the center of gravity is the heaviest spot on the ball. The weight block inside the ball is a dense material, and when it's off center, it creates a heavy spot in the ball. Well, wherever that heavy spot is in relationship to your axis point or track will help determine how the ball rolls down the lane. So it's very important not only to put the core at certain angles with your layouts, but you also want the ending heavy spot to be matched up with the core angle that you've desired. Here we have the Lane 1 dart. Okay, and there's the pin. This represents the tip of the core. And right where our label is the center of gravity of the bowling ball. Okay, now when you're laying out a ball, you want to put the pin and the center of gravity at different angles to your track. So first we want to make sure that the center of gravity is where the label is. So we're going to put this on the scale and show you how to find the center of gravity. Okay, now that the ball is in the scale, we're going to find the exact center of gravity of the bowling ball. How it transposes to the surface. It's approximately where the label is. We're going to show you how to find it exactly. First, you draw a line on the ball, approximately where it's supposed to be, and then balance the scale. So we move these sliders until the scale balances. In incremental steps, just squeezing them together. Squeeze the bar and the weight. And now, once it's in balance, we're not going to touch these sliders anymore. All we're going to do is rotate the ball left or right to adjust the scale. So now we rotate the ball 90 degrees. Grab the two ends over here together and rotate the ball. Nice and easy, 90 degrees. And now we have to balance the scale without moving the sliders. As you can see, the needle is pointing up, so we have to rotate the ball towards the inside. Just squeeze the ball cup with your fingers in between the ball and the ball cup, and that'll move the ball for you. Okay, now the scale's in balance again. Now we're going to draw a line. Okay, we got two more steps. We're going to turn it 90 degrees one more time. Now this needle is pointing down, so we have to rotate the ball to the outside. And the scale is just about in balance, and we draw another line on the ball. Okay, now we're going to rotate the ball another 90 degrees for the last time. And rotate the ball until the scale balances. As you can see, the needle's down slightly, so we're going to rotate it to the outside the weight until the needle balances, which it is. And draw another line on the ball. Okay, now there you have it. You have a box right here. The center of that box is the center of gravity. Okay, now what we need to do is find the bowler's positive axis point. In order to do that, we have to take one of their older balls that they're using and follow the track on the ball. If there is no track, then you would use an oil ring closest to the thumb and farthest from the fingers. So what we're going to do is map that out, finding the track, and follow it all the way around the ball. Okay, there you have it, marked all the way around. Now, when I put in your ball spinner, what we have here is a lane 1 axis finder, which is basically takes the place of a ball spinner, rotates the ball. And now you want to position the ball so this line does not wobble. Okay, just shift it around and spin it until it comes as tight as you can get. And then at the top, you mark the ball, and that's your positive axis point right there. Okay, now you take the measurements from the center of your grip. So what we're going to do is find the center of his grip, span of 4 inches, so it's 2 inches. Okay, so there's the grip center, and here's your midline going straight across. Now what we're going to do is draw a perpendicular line to your axis point. And there you have it. Now you take these measurements from the center of your grip. These are called the coordinates. Okay, starting from the grip center, we have 5 3/4 inches over, and we're going to take the distance how far above the midline, which is 1 3/8. So for this person, their positive axis point is 5 3/4 over and 1 3/8 up. Okay, before we go any further, we're going to explain and clarify a little bit what we mean when we're talking about angles, core angles. Okay, this is our diamond core, as you can see it inside this clear plastic buzzsaw. This is a pin-in ball. The pin and the center of gravity were both in the same location when we started. Okay, there's 3 ways, standard rotations of a bowling ball. Okay, the core can rotate perfectly end over end, and this is basically a 90-degree rotation angle to your pap. Or you can put the core on its side, and this is at a 0-degree angle to your pap. Okay, as you can see, this is a stable position. There's no wobble. This is like a spiral football pass. Okay, now the third angle is called the 45-degree angle, which is called leverage weight. This makes the core wobble. Okay, now because of this wobble, the core is going like this inside the ball and generating a lot of force. Leverage weight is the perfect blend of skid and hook. In this segment, we're going to show you how to lay out the ball for each of these 3 angles: 0 degrees, 45 degrees, and 90 degrees. First, we're going to show you the 0 degrees, called axis weight. What we're doing is we're putting the pin on the positive axis point of the bowler's pap. We found that the bowler's pap was 5 1/2 inches over and 1 5/8 up. So what we're going to do is kind of go backwards from this spot. So we're going to go down 1 5/8 inches, starting from the pin, because we're going to put the pin at 0 degrees, which will be right on his pap. And we're going to go down 1 5/8 inches, and then we're going to come across 5.5 inches. Okay, so right there is going to be the center of your grip. Okay, here's where the holes will go. Fingers, thumb. We've gone over 5.5 inches and up 1 5/8. And this puts the pin right on your pap. So there's no wobble, just long slide, skimming across the lane, no flare, and all the reaction will be on the back end. Okay, now we're going to show you the 90-degree layout. This is putting the pin 6 3/4 inches from your pap. This is a high RG layout. It's good for when the heads are dry, making the ball go long, or when you need to play deep inside as it cuts out the flare. So what we're going to do is we're going to go from the pin 6 3/4 inches and draw a semicircle arc. Now we're going to match up the pap dimensions from this spot right here on the ball. Going backwards, one 5/8. And coming across 6 3/4. Okay, this pin is 6 3/4 inches from his pap. It's probably going to be right in the middle finger. You would drill the ball just like that. Now we're going to show you the 45-degree layout called leverage weight. This puts the CG or the pin at 45 degrees from your axis point, or you can have both of them at 45 degrees from your axis point. So what we're going to do is put this ball compass on 45 degrees, which is 3 3/8 inches, and draw an arc on the ball. Okay, now if we want both the pin and the CG at 45 degrees, we're going to intersect those. This spot right here puts the pin and the CG both 45-degree rotation from your pap. Now we're going to go backwards 5.5 inches, or excuse me, 1 5/8 down and over 5.5 inches. Okay, there's where the finger holes would go, and this is kind of called the stack leverage, where the pin and the CG are both at 45 degrees from your pap. Now there's another type of leverage weight just called CG leverage, where the CG is going to be 3 3/8 inches from your pap, but the pin is going to be longer, more like 4.5 inches. So we'll show you that. This layout is going to be called the CG leverage layout, where the CG is going to be 3 3/8 from your pap, but the pin is going to be 4.5 inches from your pap. So let's lay that out. So we're going to draw an arc on the ball, 3 3/8 inches from the CG. 45 degrees. Okay, now we want to put the pin 4.5 inches from the pap. Draw another arc. And where these two lines intersect, that's where your pap is going to be. So now we're going to go backwards, down 1 5/8 inches and over 5.5. And there you have the CG out leverage, pin at 4.5 from your pap. The CG out layouts give your ball a more even reaction, more mid-lane roll than a stack leverage. And this is the most common for house shots. You'd drill your finger holes like this, and thumb hole like that. So now, what we're going to show you is, this is the original center of gravity. That's the starting center of gravity. But after we drill the gripping holes in the ball, the center of gravity is going to move. Well, that's going to put it not in balance with your original desired location. So the gravity balance system is going to show you where to put the balance hole to move the center of gravity back to its original location, or on a 3 3/8 angle from your pap. Okay, now that we've drilled the ball, we're going to weigh the ball up for side finger and top. Side finger and top weight actually controls the center of gravity. It tells you where the center of gravity is on a bowling ball in relationship to the center of your grip. So, we have 1 ounce of side weight. Wait, let me start that over again. I'm going to have to piece this. We're going to weigh this ball up for side weight. The static weights actually control the center of gravity, or they tell you where the center of gravity is located in relationship to the center of your grip. We have 1 ounce of side weight. Now we're going to check the finger or thumb weight. We have 3/8 finger weight. Now we're going to check the top weight. And top weight is 3/4 top. So this ball right now has 1 ounce of side weight, 3/8 finger weight, and 3/4 top. Now what static weights mean is what static weights tell you is where the center of gravity is in relationship to the center of your grip. So what we're going to do is we're going to quadrant up the bowling ball. There's 8 quadrants of a bowling ball, 4 on top, 4 on the bottom. And what we're going to do is we're going to go 6 3/4 inches from the center of your grip. That's where the equator is. Right here, the top. This separates the top half from the bottom half. So I'm quadranting up the bowling ball. Six 3/4 inches is 1/4 the way around the bowling ball. Okay, on the top half of the bowling ball, there's 4 quadrants. Quadrant 1, 2, 3, 4. In this quadrant, you have positive side, finger weight, and top weight. So if your ball, after you weigh it up, has side weight, finger weight, and top weight, the ending center of gravity will be somewhere in this quadrant. If your ball has side weight, top weight, and thumb weight, your ball is going to be somewhere in this quadrant. This is on the thumb side of the ball. Okay, here's the equator. This splits the top half of the ball from the bottom half of the ball. And remember, this is 6 3/4 inches from the center of your grip. Okay, this quadrant over here, this is negative side, thumb weight and top weight. It's on the thumb side of the ball. It's on the negative side for a right-hander. And it's on the top half of the ball. So anytime you have thumb, side thumb, and top weight, the ending center of gravity will be right here. Okay, the 4th quadrant on the top side of the ball is negative side, finger, and top weight. If you have negative side, finger, and top weight for your static weights, the ending center of gravity is going to be in this quadrant. Now the same goes for the bottom of the ball. Okay, this is exactly the bottom of the ball compared to the center of your grip. It's 13.5 inches from the center. Okay, so now you have positive side in this quadrant. Okay, on the bottom, positive side, finger weight and bottom. Okay, this will be positive side, thumb weight and bottom. Okay, over here will be negative side, thumb weight and bottom will be in this quadrant. And last we have negative side, finger weight, and bottom will be in this quadrant. So those are the 8 quadrants of the bowling ball. So now this ball here has 1 ounce of side, 3/4 top, and 3/8 finger. So that means the ending center of gravity is going to be somewhere in this quadrant. Now remember, here's the bowler's axis point right here. So let's weigh the ball up now and find out where the new center of gravity is. So because we have 3/4 top and 1 ounce of side, okay, it's going to be back towards the center of your grip because it has top weight. Almost equal side and equal top, but it's a little bit less top weight, so we're going to go about 2 3/4 inches. We're going to draw a line and guesstimating the new center of gravity is somewhere around this line. So we're going to put it back on the scale and weigh the ball up. Okay, we want to zero out the scale and go back. We're going back to the steps now of finding the center of gravity. we're going to rotate the ball 90 degrees and rebalance it without moving the sliders. We're going to draw a line. What we're looking for is that box again. Rotate it and balance it. Shifting the ball left or right until the scale balances. One last turn. Until the scale balances. Okay, now we have our box. There's the new box right there. In the center of this box is the new center of gravity of the bowling ball. Now, as you can see, the starting center of gravity is right here on the label, but after we drilled the holes in the ball, the center of gravity moved. And how far it'll move will be based on how much top weight's in the ball and how far off label you drill it. This ball had a decent amount of top weight, so it didn't move too far from its original location. But if we drilled the holes and you had bottom weight, all right, this CG would have moved all the way down here to the bottom half of the ball. You know, somewhere down there. Okay, but now when we originally laid the ball out, we wanted to put the center of gravity in the leverage weight position. So it rotated at 45 degrees to your pap. So in order to maximize the potential of the ball, we want the ending center of gravity to be 3 3/8 from your pap. Okay, and rotate at the same angle as you put the original static weights, the original center of gravity. So now what we're going to do with the balance hole is we're going to put a balance hole in the ball which will move this center of gravity back to the original position or to any other desired location on the ball. Okay, remember, here's the original center of gravity. And as you can see, it moved. And now it's only about 1.5 inches from his axis point, which is approximately 20 degrees. But we want the weight of the ball to be rotating at 45 degrees, so we have to move it back to its original location or somewhere on the 45-degree rotation arc. So I'm drawing a new arc on the ball, which shows you anywhere on this arc is 3 3/8 inches away from your pap. Okay, it can be on the bottom of the ball, it can be on the top of the ball, but any point on this circle means that the weight would be rotating at 45 degrees to your pap. So we can either move the new center of gravity back to the old center of gravity, which as you can see is slightly above the midline, but not too far, and that's going to give a very strong mid-lane roll. If we wanted to move the center of gravity up higher on the 45-degree arc, the ball will have more finger weight, and this will delay the hook of the ball. So we can decide, you know, where on this 45-degree arc you want the ending center of gravity. Here's the original location. So if you move it back to the original location, That's going to be a very strong roll. That's exactly where you put the weight in the beginning. And now the two are rotating together and they're working together. They're not fighting against each other. So, in order to put the center of gravity back to its original location, we're going to draw a line through the old center of gravity and the new center of gravity. Okay, there's the line between the two. Now, anywhere on this line, if we drill the hole, balance hole, anywhere on this line, the center of gravity is going to move in an opposite direction. So it's going to move right along this line. So if we put a hole here, that will move the center of gravity back to its original location. So now we're going to go back, drill the balance hole, and show you where the new center of gravity is after we put the hole in the ball. So now we want the ending center of gravity to be 4 1/4 inches away from the equator. So now we're going to take this gravity balancer and put this rotating line at 4 1/4 inches. Okay, so for a 5/8 amount of side weight, we're going to come across and see where it meets the line. So it's going to meet the line at 15/16 ounce of top weight. So that means if we want to end with 5/8 side weight, we want to end up with 15/16 top. Right now, currently, the ball has 1 ounce of side. We want to go to 5/8, so we need to minus 3/8 side weight. Minus 3/8 side. And we have 3/4 top in the ball, and we need 15/16 top. So we need to add 3/16 top weight. So in order to add top weight in the ball when you're taking out side weight, we have to drill the hole below the equator. If you drill the hole above the equator, you're going to lose top weight. You know, there's a lot of systems out there that there's other systems out there that tell you to put the hole in the P1, 2, 3, 4. Okay? And those positions are basically all on the top side of the ball. So whenever you use hole locations like that, you're going to lose top weight. And basically, you're having no regard for the ending heavy spot. Okay, but we know that weight in the ball, mass, controls the motion of the ball. So wherever the mass is on the ball, wherever the ending heavy spot, the ending mass is going to show you how the ball is going to react. It's going to react, if you have side weight on the ball, it's going to pull into the pocket. If you have negative side weight on the ball, it's going to hold the ball back from hooking. It's going to hook and stop. If you have bottom weight on the ball, in two-piece bowling balls, the core goes down through the center of the ball. So that's kind of almost like balancing out the ball. So if you have bottom weight in the ball, along with the core extending down through the bottom of the ball, it's like overkill. You don't need all that weight on the bottom. You need more weight on top of the ball if you're looking for a strong ball reaction at the end. So you always want to end up with top weight. So now we need to add 3/16 top weight and take out 3/8 side weight. So basically, we're going to put the gravity balancer here on 3/8 side weight over to 3/16 on the bottom here, on the top weight side. And you're going to extend this line out, and you can see it's 1 3/4 inches. So that means we have to go on the bottom side of the ball 1 3/4 inches. And we're going to put the hole right on that line. Okay, this is where the balance hole is going. Right on this line, we're going to move the center of gravity right along the line to its original location. So we need to subtract 3/8 ounce aside, add some top weight, and roughly we're going to take out about 1/2 ounce. So use your weight removal charts. We like drilling holes 2.5 inches deep. So follow along the side over here, about 1/2 ounce. Yeah, we're looking at about a 1/2 inch drill bit. So a 1/2 inch drill bit, 2.5 inches deep, and that'll move the center of gravity to where we want it to be. Now, depending on the weight of the ball, some lighter balls, there's different density materials. You might need to drill a bigger hole or go deeper with your hole. So we're going to go 2.5 inches deep with a 1/2 inch drill bit and see where this center of gravity moves to. Okay, so now we've put the hole in the ball, and we're going to reweigh it to see how far the ending center of gravity moved. You know, it's supposed to move all the way back to where we want it, but we're going to double check it. So I'm going to draw a line on the ball just slightly off where it's supposed to end up, just so we can see the difference. Okay, here's the original center of gravity. Here's the center of gravity after drilling the holes, the gripping holes. And now we're going to start by checking it right here. This is where we're going to start our box to see how far it moved and if it moved all the way to the desired location. And again, why are we doing this? We're doing this to balance the ball, balance the ending heavy spot to the original weight block location. So the ball, so the ending heavy spot is working with the core. So whatever core angle you set it up as to begin with, now the ending heavy spot, the ending center of gravity, is going to work together with the core. And that's going to give you a truer ball reaction and more hitting power. Okay. Now, we see right here, here's the new box. Okay, it moved from here to right there. We need to go just a little more to be exact and put it back on the original location. So what you would now do is now we just go back, drill the hole a little deeper, and that'll move that the rest of the way so the ending center of gravity is back to its original location. And now you know where the ending heavy spot is in relationship to your PAP, and or whatever the desired location is that you're looking for. You know where it is. You know how to move it. And so now, based on how this ball rolls down the lane, if you want to duplicate this ball reaction, all you would do is drill a new ball, same ball, with the same core angle, and now put the ending heavy spot in the same location. If you're using different top weight balls, which it's hard for a pro shop to have all the same top weight, the hole location is going to be different from ball to ball. You might have one hole location here, you might have one hole location up here to take out top weight, or you might have it even farther down to add more top weight. But as long as the ending center of gravity is in the same position on both balls, it doesn't matter where the hole location is. The balls are still going to roll almost identical. And that's what we're looking for. Okay, now that we've found the ending center of gravity of our leverage weight drilling, and we moved it back to the original location, so the final ending center of gravity is back to the original location, we're going to go back to our pin axis ball here and show you what it's like to have a true axis weight ball. The pin axis, the pin is on our axis, and now we're going to find the ending center of gravity, which the intention was to put it on the pin, on our PAP. Many axis weight balls have the balance hole going right through your PAP. And that's one way to drill an axis weight ball, but that does not put the ending center of gravity on your PAP. And because of that, you get two different ball reactions. So you can have an axis weight ball or a pin axis ball, let's say, one with the hole on your PAP, and another axis weight ball with the ending center of gravity also on your PAP. So you can see here, the pin is on our PAP and the ending center of gravity is just about right on top of the pin. And you can see the hole location. It's past the equator. The hole is not on the PAP. The hole is off the PAP, bringing top weight back in the ball and moving the ending center of gravity to your axis. This is a true axis weight ball, a perfect axis weight ball. This is going to give you more length and a stronger back end motion. Great for playing outside and down the boards. With the hole on your axis, you're going to end up with bottom weight, and that's going to make the ball roll earlier with less motion on the back end. So this shows you leverage weight, CG, and this is axis weight, CG. CG axis, CG leverage. Before we go, I'd like to talk to you about our latest ball called the Lane 1 Difference. The Lane 1 Difference is the hardest hitting ball in the market. It utilizes our plated asymmetrical diamond shaped core, which has the highest intermediate differential of all time. It's a .040, which gives you a quicker reaction off the dry, which means sharper entry angle in the pocket. We also have a new bow tie location, not going from the PAP through the pin, but from the mass bias through the pin. This allows us to use all pin under drillings, which is going to give you more mid-lane roll for better traction on oil. Yet, because the bow tie is going to be still above the fingers, you're going to get the back end reaction like a pin-up ball. So you have the best of both worlds. Now you know what the lane 1 difference is all about.